In the infinite, cold, and dark depths of the universe, imagine a signal that lasts only 1,000th of a second, yet shines with enough energy to illuminate entire galaxies. This signal comes from far beyond our own galaxy. It is so powerful and so fast that astronomers can detect it only with the help of modern technology. This is precisely the phenomenon that scientists call fast radio bursts, FRBs. As the name suggests, FRBs are short but extremely powerful bursts observed in radio frequencies originating from space. These bursts are among the youngest and most exciting cosmic mysteries we know. Research into the sources, nature, and energy mechanisms of these radio waves is advancing rapidly. These discoveries are so recent that the history of FRBs is often summarized under the title, "A Decade of Fast Radio Bursts." In other words, this field has been on the scientific agenda for only the past 10 years. So how did this decade begin? The spark that ignited FRB research began with a paper published in 2007. This event marked the starting point of modern FRB science. This historic discovery is known in the scientific world as the Lorimer Burst. The 2007 discovery paper showed that this brief radio signal had been recorded for the first time and that it originated from the depths of the universe. The Lorimer Burst was only a momentary flash, but the energy it carried and the immense distance it traveled proved that we had uncovered a new and powerful class of cosmic phenomenon, something never before observed. Following this single signal, astronomers around the world began searching for these short bursts using radio telescopes. Over the years, it became clear that these bursts were not isolated events, but instead a mysterious phenomenon occurring continuously throughout the universe. Yet each new discovery brought great questions with it. How common were these bursts? What kind of celestial object could release such enormous energy in just milliseconds? And most importantly, what was their source? These questions directed scientists toward the most exotic and extreme objects in the universe. Understanding the source mechanism of FRBs poses a major challenge for astronomy and physics. These bursts are incredibly brief and their energies are unimaginably high. The question, what is the source of FRBs, remains at the heart of scientific investigation. So which cosmic monster could produce such a powerful radio signal? Scientists have focused on one of the most extreme objects in the universe, magnetars. Magnetars are a special type of neutron star. The remnants formed after a massive star explodes as a supernova. A single teaspoon of magnetar material can weigh hundreds of millions of tons. What sets magnetars apart is that they possess the strongest magnetic fields known in the universe. These magnetic fields are so intense that if you approached a magnetar, the magnetic forces could tear apart the atoms in your body. When this enormous magnetic energy suddenly collapses, or when the crust of the star cracks, theorists believe it could trigger an FRB. Sources clearly show that magnetars are among the most significant candidates being studied as FRB origins. This is not just a theory, it is one of the hottest research topics in the astronomy community. If FRBs truly originate from magnetars, it would establish a revolutionary link in radio astronomy and high-energy astrophysics. Even the titles of studies questioning this relationship demonstrate how intensely the scientific community is focused on this possibility. A deeper investigation of these candidates will help us understand why FRBs are so rare and powerful, and how this energy is released. The search that began with the Lorimer Burst has accelerated thanks to modern telescope technologies. We are now far better equipped to detect FRBs and determine their locations. One of the major players in this field is the telescope used by the CHIME/FRB Collaboration. CHIME is a massive radio telescope capable of continuously scanning a large portion of the sky. This collaboration has rapidly expanded the FRB catalog and played a major role in helping us understand the statistical properties of these phenomena. To see how current this research is, one only needs to look at the sources. The CHIME/FRB Collaboration has published a report containing the latest findings from 2022 to 2024, providing a constant stream of data to the scientific community. This steady flow of information seeks answers to crucial questions such as how FRBs are distributed in space, how frequently they occur, and whether some bursts repeat. The field of FRB research is progressing so quickly that scientists must prepare yearly assessments to keep up. A paper titled Fast Radio Bursts: Recent Progress and Future Prospects summarizes the current state of this rapidly advancing field and offers a roadmap for the coming years. This means our knowledge is continuously being updated. Fast radio bursts are a powerful reminder of how much the universe still hides from us. Although they were discovered only a decade ago, these bursts challenge us to understand the most extreme physical conditions imaginable. In summary, the journey that began with the Lorimer Burst in 2007 has led us to a strong hypothesis. Magnetars may be the potential sources of these phenomena. Powerful telescopes like CHIME accelerate scientific progress each year by increasing the number of detected bursts and providing detailed data. FRBs are more than mere radio signals. They are cosmic probes that allow us to use intergalactic space as a laboratory. As we continue to listen and investigate, we move one step closer to unveiling the secrets behind the universe's most powerful explosions. In the coming years, once we identify the true origin of FRBs with certainty, one of the greatest mysteries in cosmic history will finally be solved.